Hello, my mathematicians. It's Miss Gray. I'm sorry that I can't be there with you today. I'm enjoying some time with my son. So I did want to leave you a quick video just to quickly refresh your memory on how to graph a linear function in slope-intercept form, and then also work through one or two application questions. I trust that you are in your best behavior and you are showing maverick pride. Okay, so as a reminder here, we are looking at the function of a slope-intercept form. That's the linear equation. So we need two things. You already know slope-intercept form. We need slope and a y-intercept. Okay, hence the word slope-intercept form. So once we determine what our slope and our y-intercept are, you are good to graph that equation. I always want you to start by plotting and starting with your y-intercept first. That's why that B, I remind myself that B is beginning, begin. And then we're going to use our slope to determine more points on the line. And then we're always going to connect them with a solid line because the equation has an equal to, its arrows at the end, okay? It's going to continue on. So let's take a look at number 10 and see how that looks like. So the first thing I'm going to do, I'm going to identify, make sure I have a slope and a y-intercept. So my slope is here at 2 over 3 because it's the only one attached to that x variable. And my y-intercept is at -4. So I'm going to graph this point by starting at my y-intercept. So I'm going to start here at -4. I'm going to put a point. And my slope tells me that I'm going to go up 2 and over 3. So starting at your y-intercept, I want you to go up 2 and over 3. And I apologize, I know that this is hard to see on your paper. Just do the best you can. We're going to go up 2 over 3, 1, 2, 3. And I'm going to do this until I run out of graph. And just like I went to the right in my graph, I always want to go back. Okay, so if I go up 2 over 3, I can go over 3, 1, 2, 3, down 2, and there's going to be my next point. Okay, 1, 2, 3, down 2, my next point, and then I'm just going to connect these with a solid line. Of course, your line's going to be straighter and hit all the points, but that is the graph of the equation y equals 2/3 x minus 4. So try number 11 on your own. And here you go. Hopefully you stopped the video and you took a look and you're getting the same thing I am. So I identified my slope, which was -1/2. Tells me that I'm going down 1 on my y. My change of y is 1, and my change of x is over 2. So I started at my y-intercept here, which is at +5, and I went down 1 and over 2. And I did that until I graphed and went all the way out of room, and then I just did it in reverse. Okay. Let's take a look at number 12 together. Okay, so here I have number 12, and I'm going to start the same way. First, I'm going to identify my slope. Well, my slope is 2. Okay, it is attached to that x value. So I know my slope is +2 over 1. Tells me I'm going to go up 2 over 1. What is your y-intercept? Did you say 0? If you did, you're correct. My y-intercept is 0. It's not there because remember, we don't, in algebra, we do not write +0. So if it's not there, we know that it's here at 0. So hopefully you started, you plotted at 0. And now, same thing, we're going to go up 2, 1, 2 over 1, up 2, 1, 2 over 1, and so forth until we run out of room. And connect it with a straight line. And when you do so, your graph should look something like this: positive slope with 2 over 1 as the slope going through your origin. Okay, hopefully that was a great refresher on graphing in slope-intercept form. So now let's take a look at writing linear equations in a real-world application. Yes, your favorite word problems. So remember, keywords for slope in word problems: per, each, every, okay? Those are all words that trigger us to know that slope is coming, whereas y-intercept, beginning, initial, start, okay? Those are all y-intercept. So let's take a look at number 13. So here we have the water pressure measured in atmospheres. At 0 meters, the pressure is 1 atmosphere, and the pressure increases by 0.1. Okay, so it's asking us to write a linear equation in slope-intercept form to model this equation. So I'm going to note to myself that slope-intercept form is y equals mx plus b. And what are the two things that I need to know in order to write it in slope-intercept form? I need my m and I need my b. Okay, so let's go back to our scenario. So what did I learn? I learned that the pressure increases, which tells me that I'm going to have a positive slope, by what? At 0.1. Okay, so I know my slope because here the keyword per, at 0.1 per meter. Okay, so my slope is 0.1, or you can write 1 over 10. Okay, that's my slope. What is our y-intercept? What's the beginning? What's the starting? You guessed it, the starting here at 0 meters, meaning at the beginning, at that y-intercept, it's 1. So my slope, my y-intercept is 1. So now I have everything I need to write this equation in slope-intercept form. I have an m and I have a b. So I should have y equals, and since it's positive because I'm increasing, 1 over 10x plus 1. Let's look at the next one. So I have Greg driving a remote controlled car at a constant speed. He starts the timer when the car is 5 feet away from him. And if the speed of the car is 15 feet per second, they want me to write a linear equation. So first, let me pull out some of these key things. I see this keyword here, per, which tells me per is a keyword for slope. So my slope is what? It's 15. My slope is 15. Okay. And now, where did Greg begin? Where did he start? Where is his initial? Well, he told me that he starts when the car is 5 feet away. So what is my y-intercept? It's 5. Okay. So now I can write this in slope-intercept form. I have y equals 15x plus 5. I hope that this helped. If you needed assistance in completing your assignment today, we will go over anything that you have questions on Monday when I return to campus. Have a great weekend. Work hard. Show lots of Maverick pride.